glad to be here. I think it's been 5, 6 years. Actually, Carney invited me to give a talk. I hope I've got a few new things to say, promising things. So first, I'm a histopathologist by nature and by background, and I run a molecular pathology diagnostic service here in Birmingham, the Queen's Hospital, which is indeed a reference center for mutation testing in GIST. Been here for 15 years, I think now, for KIT and PDA-alpha. So I'm not doing research as such. I'm here to be sure that the most updated tests, which could be relevant for the clinical management, are here up and running, validated in my lab to offer the best service on the top of the histology diagnosis for GIST. So again, I'm not going to feedback of any research because I do not do, or very little, but maybe to explain if needs to be how we make a diagnosis and what are the new tests we are setting up. Again, could be, as Jen said, relevant soon if treatments are made available, or even trials to make sure that we don't miss any opportunity of labeling and typing the tumors the best way. So again, the first, you all know that, but the first step after the clinical I would say, assessment is just to make a diagnosis of GIST. And to be honest, our life has been it's quite easy to make a diagnosis of GIST if you have a few cells, and we don't need a lot of cells. As you know, we could make a diagnosis on a small biopsy, which can be or fine needle aspiration, what we call cytology. We have extremely powerful antibodies, highly sensitive and highly specific, much better than a few years ago. Even I think last time I came again, we didn't have the DOG1 antibody, which is highly sensitive and specific. So basically, the diagnosis of GIST for a pathologist is easy. Maybe I shouldn't say that, but it's easy. And we can make a diagnosis on very small specimens. And those small specimens, again, we have improved, I think, the way we process them. They're also suitable for any molecular testing to follow, KIT and PDA-alpha mutation, but also SDHP, BRAF, and NTRK, possibly PDA1 testing if needed as well. So again, we can make a diagnosis of GIST on small biopsy, and of course, after, if the tumor is excised, we still look at it, sample, make an assessment on several pieces of the tumor. So the tumor can be very big, and actually the bigger they are, the less aggressive they are. Having a large tumor is not necessarily a bad thing in terms of prognosis. It's very true for all tumors. If you have a large tumor in your body, which is still resectable, actually, means that the tumor has grown very slowly. So it's not a bad prognostic feature. The size is not as such. Because actually, the record, we can have tumors, we could be a few kilograms, actually. But most of tumors nowadays are diagnosed at an early stage and can be between 3 and 5 centimeters. The histology, so we make a diagnosis, we type the tumor, and we can, from where the cells are organized each other, make a prognostic value. You know, the grading of GIST, which is based currently on the site of the lesion, the number of mitoses, and the size. And you know that the gastric GISTs are less aggressive than the intestinal ones, but we're not exactly the same tumors. And we have a grading system. The grading system changes about every 5 years. And it's not just only to make our life difficult or your life more difficult. It's just because those grading systems are updated in view of new data, which are looked at retrospectively. That's very true for all classification of cancers. There is an upgrade made mainly by the World Health Organization every 5 years, which again is based on new data. It's not because somebody has decided to change it. So the grading systems, this one on basically this one, very much similar. And we assess the risk for relapse or metastatic spread of the GISTs. And that, again, is relatively easy for us to do. Pathologists being used to count cells and look at them and interpret immunohistochemistry. So now what's next? Now I think it's very well admitted that the mutation testing is fully part of the diagnosis. If it's not done on the same site as the diagnosis was made, there are enough centers in the country, and there will be more if you wish, because you know I have a few slides at the end of the show to explain that the reconfiguration of genomic testing in this country, in England at least, with the genomic laboratory hubs, is offering all patients the possibility of having tumors widely sequenced, whole genome sequencing, and GIST, part of sarcoma, is one of those tumors, which I think is great. It's starting, it's not very much up and running, but at least there is a real will from the government, which we all like, of having this happening, and I think we should be proud of being an NHS, because actually it doesn't happen in all the countries around. So the mutation testing is now routine in many labs. We've been doing that, again, for about 15 years. And we know that the mutations which are relevant clinically are distributed along exons 8, 9, 11, 13, and 17 of KIT, and 12, 13, 14, and 18 of PG-alpha gene. And that, again, can be done within a week or two max at most in our lab and others. And you know the mutation is mainly predictive to response to tyrosine kinase inhibitors, imatinib, sunitinib, and so. And there is one mutation which is well known not to convey primary resistance to all those drugs, which is the D840V in exon 18 of PG-alpha. And this is a mutation which is very bad in terms of predictive, conveys primary resistance. On the other hand, the same mutation conveys very good prognosis. So it's a paradox, isn't it? And that larger tumors, if you have a large tumor in the stomach, it's likely to be an 842, because those tumors can grow very, very big and not having any symptoms. So the good news is it conveys a very low indolent behavior to the tumor. The bad news, if by chance you will need treatment, the tyrosine kinase inhibitor therapy will not work. So again, these have to be pragmatic, and to explain, I just want to, and most of you probably know how it works in histology, but there are many steps for us to get able to do the mutation testing. It starts by having a block, paraffin block, embedding, cutting thin sections, putting in our slides, and extracting DNA from that. So it just explains why there is a delay. It's not like this, you put in the tube and the following day it works. Again, we need time. I'm begging for time, because we are high pressure for daily service. We do our best, but infrastructure and also the checking, the double checking and everything, we do need to want it seriously. And we have also submitted to accreditation requirements and quality control checks. So again, we do our best, but we can't be done in half an hour. And being a reference center, we receive samples from the labs. So of course, the turnaround perceived by oncologists and by patients can be longer, but in our lab, we do our quick, but had a few weeks before deciding on sending the sample, putting in an envelope and that sort of thing. So just trying to justify sometimes the turnaround looks longer than it is really. So how do we do mutation? Classically, it was what we call Sanger sequencing, which we do still. Actually, it works nicely. So that it looks like lovely, colorful spectrum graphs. Actually, we can interpret each color corresponds to one of the nucleotides. And actually, you can have a missense mutations, easy to interpret. But in GIST, as you know, the most frequent mutations are exon 11 of KIT, and they can be extremely large deletions, which I think the reason I'm saying that is for NGS, next generation sequencing, you're all familiar with this word now, has implication technically because NGS technology can very much miss the large deletions, and that adds to the complication of the technology to be moved to NGS. We've done that now, but again, we need to be aware of this problem eventually. So again, it looks like a bit messy like this for people not knowing how it looks like, but when you have a deletion, because you have always two alleles in genes, I don't know if you know, in chromosomes. So you have one which has a mutation, which doesn't have. And when we do sequencing, we also sequence the normal cells. So it could be a bit messy like the line below. But again, that's part of the fun, knowing how to interpret the sequencing. NGS is a next generation sequencing, is a lovely technology which allows us to do multiplex testing. Instead of doing exon one by one, or gene Y by 1, we can put all in one go, in one tube, in one run of the machine. It's absolutely fantastic, almost unlimited. Of course, in practice, it's not as easy and easy to do, actually, but it's improving so quickly and so much that we're very much now in a position to offer NGS testing in routine diagnosis. We have here in our department an 8-gene panel, because the more genes you put, the more DNA you need, the more sophisticated the interpretation is. You have those multiple information. Too much information sometimes can be detrimental for the routine test, for the turntime. But actually we get used, and also we get supports from bioinformaticians and softwares. So we have this panel we have in the department, which tests for KIT, PG-alpha, and also BRAF, which has an interest in GIST, as you know. But of course, next-generation sequencing can be used for wider sequencing up to whole genome sequencing, okay, which is on the left column, the second column. And that's what NHS England is willing us to offer all patients, all the genome of the tumor sequenced entirely for all patients. And that's the aim. So it has to be step by step. We can't move from what we are now to whole genome sequencing for all patients. But sarcomas, including GIST, then, is a priority for having whole genome sequencing done for NHS England. So the Genomic Laboratory Hubs, I'm part of the one for the West Midlands, for my lab, and it's part of it, is aiming to offer patients whole genome sequencing for all GIST. But we do need frozen tissue for that, which is not difficult to get, actually, for GIST. But hopefully, I can't give you a deadline and a time frame, but we have to rush on making that available. We're talking about 2 years. But in the meantime, we have facilities through the hubs to do wider sequencing that we currently do. And the good news, I'm sorry, is funded. It's nationally funded, which means free for all patients. And there will be no postcode lottery anymore, I may say, if there was, because England, I have to talk about England, is divided in 7 territories for 7 genomic laboratory hubs for every patient, wherever he lives in England, to be attached to one of those GLHs and to have not only for GIST, but all cancers, the best sequencing, molecular profiling done quicker and for free of charge for patients, which is very important. Okay, what's new in GIST now on the top of the KIT PG-alpha mutation, which is very well known, is the GIST which are not mutated, the wild type. There are many ways of calling them, but it's the non-KIT PG-alpha mutated GIST. So there are syndromes, as you all know probably, which we are not expecting finding GIST mutations in KIT or PG-alpha is neurofibromatosis, Carney and Carney Triad. So the tumors look very much like GISTs. They have the same profile of expression on immunohistochemistry, the DOG1 I was talking earlier, but they don't have the KIT mutation or PG-alpha mutations as a molecular background. The tumorigenesis has developed through other alterations, which are NF1 or SDH germ mutation for Carney syndrome. Now we know, it's been a few years, we know that when we can't find a mutation in KIT or PG-alpha, which is about roughly, in my department, 12% of tumors, we do need to test them for BRAF mutation, and we find mutation in less than 1% of the GIST, and SDH expression by immunohistochemistry, and SDH expression can be lost related to germline mutations or sometimes sporadic. So I think SDH loss of expression in the tumor is encouraging us, referring the patient, indirectly, I'm not referring patients myself, but encouraging the oncologist to refer the patient to a geneticist, as you know, to make sure that there is no germline mutation, which has implication for the follow-up of the patients and the family potentially, okay? And what is new, and I put that in the title, is NTRK. NTRK, we're all excited by NTRK because basically we know that a very small proportion of those GIST have a translocation. 2 chromosomes have been put together, and one chromosome has a gene called NTRK2, and that has potential implications for treatment I've tried to explain. So Carney's Triad, actually you probably know, better than me maybe, the sporadic syndrome is not a mutation, and it's usually in young females with other lesions that cysts which are all benign, and there is no inherited disorder in the background, which means it's sporadic, which means the parents were not carrying a gene. It's just happened, unfortunately, in this patient, but not due to inherited alteration in the genome. The familial paraganglioma and gastric gene, or Carney case, the background is most of the time a germline mutation in that gene called SDH, okay? And the patients are more at risk of developing cysts and what we call pheochromocytomas or paragangliomas, which are tumors in the retroperitoneum from adrenal gland. Again, so basically in practice in our department, we test, as I said, the wild-type cysts for SDH, immunohistochemistry, very easy test, costs nothing, sometimes difficult to interpret, but quite efficient, and BRAF mutation again, and we refer that to the oncologist, and after that they may have or not implications for the treatment. But if you wish, in a way, finding one of those alterations validates indirectly the fact there is no mutation in Kitt-Bereshoff, because those mutations are mutually exclusive. So what do we have in GIST? That's probably not readable here, but lots of research are done finding some of the types of alterations. I mentioned about NTRK, which I will say a few words. Few papers have actually found amplification in a gene called FGFR1 could be promising and targetable, but we are from far for having drugs targeting this gene, but why not? NTRK, tropomyosin receptor kinase. Actually, this NTRK gene can be altered in many, many types of cancers, not only GISTs, but carcinomas, pediatric sarcomas, and so on. And actually, there are 3 genes, doesn't matter very much, but there is a drug, at least one drug, which is on trial, will give very promising results for those tumors, whatever the tumor is, having this translocation. So it's a source of hope would be in GIST a very low proportion. We don't know exactly the proportion of GIST who have this translocation. But we don't want to miss any if this drug will be licensed. And I've been to board meetings with the companies, and they're very exciting. The results can be extremely impressive in tumors harboring those translocations. So the strategy is now how we're going to test tumors, and which tumors will be licensed, will be benefiting first from the drugs when it's licensed. But this is on the list definitely. The assessment is quite complex, but we've set up in our department all the techniques already to be ready to go, and even if we have very few requests. So we can have a combination of immunohistochemistry, of fluorescent in situ hybridization, or RNA, or NGS again. But all those techniques are quite complex and probably complementary to each other. So we made the choice of developing them all and see how we're going to work with them. So immunohistochemistry, again, with various antibodies. There are 3 chromosomes. For GIST, is NTRK3 would be interesting. In some of the cancers, in 2 and 1, we have all these 3 fish tests up and running. I'm not advertising for the department, I'm just saying that what I tried to say at the beginning, we try to be ready for not being surprised when the first request will come through. But we are from far again ready for having the drug licensed. And finally, the title was encouraging me to talk about immunotherapy, which I like because we are a test center for PD-L1 test in many types of cancers in our department. I don't have any gist information about treatment. Again, I'm not an oncologist anyway, but actually, if we were to ask assessing gists for various alterations could make the tumors suitable for immunotherapy, we are ready to go because we do lots of those tests in other cancers. I've tried to make a draw here for PD-L1, which is the targets of the immune system of choice in many types of cancers, in lung cancers, in melanomas, in head and neck cancers, in breast cancers, in urothelial cancer, for bladder. Drugs are licensed and give very impressive results. There is nothing yet licensed in sarcomas, but there are a few studies ongoing. So basically, normally, that is the tumor cells below. and on the top is a lymphocyte. So tumor cells is supposed to be recognized as a foreign body, if I may say, a stranger, and the lymphocytes actually should destroy by sending some molecules into cells to destroy it. Okay, that's normal thing, and probably we all have every day a few of those naughty cells in our body which are inhibited and killed by immune system, and that saves us for having a cancer growing. If the same tumor cells in a naughty way express PD-L1, the lymphocytes expressing PD-L1 are misled in a way and say, well, they're inhibited. They say, I can't do my job because the cells send me a message that actually I cannot kill it. So the idea is for those tumor cells expressing PD-L1 is inhibiting this interaction between PD-L1 and PD-L1 in order immune system to be restored in its mission and role to destroy tumor cells. And that works in practice. All the drugs have been licensed. Again, I said a few things about lung, impressive results, head and neck, and bladder and breast. And we test about 1,000 tumors every month for PD-L1 expression to make sure patients don't miss the opportunity of having the right treatment, which is extremely exciting. Another way of assessing for again, the tumor for its suitability for responding to immunotherapy would be the number of mutations within the tumor. Not all tumors have the same number of mutations. They all have a huge number of mutations in cells, but there are some which are more than others. And the more mutations you have, the more likely the immunotherapy will work. So we are on the way of developing ways in sarcomas as well as in carcinomas, reliable tests to assess for 500 genes in one go, which is quite challenging technically, especially in a small biopsy, to give an idea of the level of mutations, which will make more people suitable for the treatment. So the idea is about the same. The more mutations there are within a tumor, the more likely they are the immune system gets excited and is inducing lots of new lymphocytes, recognizing those many foreign bodies, if I may say, and killing them. So but if you have PD-L1, actually that would not work again. So it's been shown clinically that, again, those tumors having high mutation burden, and within a type of tumor, not all tumors have the same mutation. For example, in GIST, from what we can read per data, the tumors with the mutation in PG-alpha have more mutations than the tumor within which have KIT mutation. Has to be confirmed, has to be validated if that would be clinically relevant, but actually, again, that's research. And but research very well funded, and we hope that at some point there will be nice results coming through and maybe new drugs licensed. I said I wanted to finish with the genomic laboratory helps. I think I said it during the talk. I couldn't resist because again it's exciting. But we have now the facilities and resources, even if it's not fully ready, for offering all patients very soon in a very secure way, accredited way, funded way, the best service, I would say, on the top of histology, of course, for having all tumor screen, which could be used, of course, for the diagnosis, immediate management of patients, could help also not missing an opportunity for patients to be recruited in trials, a bit more than I currently do in routine, and of course, accumulating data for research. Because those old tumors, we have large series of tumor, we have high whole genome sequencing, those data can be used by researchers and research labs to identify new targets and to help validating in collaboration with pharma's company and everything. So it's a fantastic project, I must say, and NHS funded, which we all like. Thank you very much.
Thank you very much, Phillippe. I expect some of you who are new to GIST may feel a bit overwhelmed by some of the codes and expressions used there. I remember feeling exactly the same when I came to my first GIST Support UK meeting, which was also in Birmingham. All I would say is, since that was in 2010 when I came here, obviously it's not everybody's cup of tea to learn about the minutiae of GIST histochemistry and all those sorts of things. But The one thing that's sort of happened over the last 9 years, in my experience, when we first started, mutational testing was not standard. So you were told you had a GIST, and that was it. An identification of a GIST was that it was obviously a sarcoma as opposed to a carcinoma. Now, through time, what's happened, and it's becoming more rapidly clear, it's quite important that you know what type of GIST you have, because they're not all the same, and they do respond differently to different types of, they will require different types of treatment. So, for example, it may be in future that if you're diagnosed with a certain type of GIST, they wouldn't automatically, we're not there yet, but they wouldn't automatically say, right, you have to go on to imatinib, because that might not be the most suitable drug for your type of GIST. So if you've recently been diagnosed with GIST, as Phillippe says, it takes a few weeks for the sample that they take when you've had your operation or your biopsy to be mutationally analysed. So 6 to 8 weeks is normal. But I would recommend that you do ask for your pathology report. You might not necessarily understand it, but you need to know what type of GIST you've got. Because it could be important for your own sort of management of your treatment moving forward. You know, at least know what you've got, and then, you know, if you want to examine a bit further what treatments might be best, then you're just putting yourself in a stronger position to be able to control that. So has anyone got a burning question now they want to ask Phillippe, or could they, you know, are you happy to wait till later? Yeah, I mean, how many people in the room actually know what type of GIST mutationally they have?
You mean in what gene? Like in exon?
Yeah, do you have an exon 11, a wild-type GIST, a exon 9?
Interestingly enough, yesterday I went to see a registrar at Coventry Hospital, and my first GIST was 3 years ago, and it was 8.5 kilos when it was removed.
Oh gosh!
And it obviously bled into the tumour, because when they removed it, there was 9.5 litres of liquid within the sac.
Yes.
So they took 41 pounds or whatever away from my
Wow.
gut, and up to 20% of my stomach at the time. Only yesterday, after I've had my second operation, which was the 18th of December, when they were going to take my stomach away, and actually when they went in, they didn't.
No.
They removed 4 GISTs from behind the stomach, and they removed a node from my kidney that had got a GIST attached to it. They actually told me yesterday what it was.
Yeah.
And it's quite interesting looking at the particular, I can't remember, it's PD, whatever it was.
PDGFRA?
Yeah. Originally, they said to me, go off and enjoy life, it's not going to happen again. But it's interesting that it's mutated, and they're now putting me on Glyvec. And it was only yesterday I actually found out from the registrar, who was, I'm going to say, a newbie on the team.
Yeah.
And I said, have we got the details of the histology back? And he said, no, we've only got the histology from January, just after the operation. We haven't got the new histology, because I gather it's with you in Birmingham. So I will give you time to analyse it. But it looks as though it's mutated, so now they can use the imatinib. And
So
I'm
what mutation did they say you had then?
Well, he said it was this PD whatever, and it's moved on from one that would not respond to Glyvec to one that now will.
Right, okay.
So, and that was quite interesting listening to what you said there, and it sort of substantiated what's happened in that process of 3 years. And I was completely, you know, naive and didn't understand it. When he said go off and, you know, have a bottle of champagne and enjoy life, I thought it's all over, you know. And to be quite honest, from where I came, when I went in on a 111, because I'd been waiting for scans, and I then got to the point where I just felt so ill. And I went in on a 111 and they said it was terminal. You know, it puts a completely different
there's a different
emphasis on it.
There's a different perspective. I mean, obviously, as time's gone on and you know, researchers delve deeper into these things, obviously they're now aware there are more different types of GIST, and they will probably find more. I mean, within the Paul's GIST group of patients, that's sort of a basket of all the ones where they haven't yet identified mutations, but through time, I'm sure that will expand, and they'll have lots of different subtypes. Yeah. and identify targets. But the other thing that's happened that I think obviously has assisted in your particular case and others is that obviously the guidelines, national GIST guidelines, were updated. Judith and I were very heavily involved in that process, and since they were launched, I mean, it does mandate that mutational testing should happen as standard. So, you know, you shouldn't be advised by whoever's done your operation that, sorry, we can tell you you've got GIST, but no mutational testing has been done. Yeah. You know, you should insist that it is done, because it's important that you know what type of GIST you've got. Yeah. Anyway.
Can I ask one more question?
Yeah, go on. Sorry.
I've got a mutation in exon 13, and my GIST was excised in November. Can that then mutate into a different gene? Or will it always be a mutation in exon 13?
Yeah, that's a very good question. No, it's most likely to be the same mutation seen all along the story of the disease. If you wish, that those mutations occur at a very early stage in tumor development, and we've done studies published as well. If you have incident finding, you know, on the specimen resected for another lesion, but the GIST, you found 2 millimeter GISTs in patients, they already have the key mutation. And so what can happen sometimes under treatment, if you have resistance or relapse after having initially responded to treatment of the patients, you can have another mutation happening in the tumor, which would explain potentially why the tumor doesn't respond as well as it used to on the treatment. But we have second or third or fourth generation of drugs which could go against that second mutation, if you wish. But no, that's a very good question. It's maintained all along.
All right, Judith's got a question.
You mentioned that some of the testing that you do needs frozen tissue rather than formalin and wax blocked. Do all hospitals keep frozen tissue?
Okay, again, another very good question. The answer is no, and the body should be. We've been in big hospitals, I would say, or teaching like ours, we've been freezing for ages. The resection specimen, all the GISTs resected, surgeons were currently sent what we call fresh to the lab, and we were sampling, put a small sample or sample in nitrogen, which is freezing immediately, best way, and storing in a biobank. That is on the resection specimens, not on biopsy. That doesn't exist anywhere yet. But again, attached to this reorganization of genomics, the genomic library hubs is now going to be mandated and mandatory, having freezing facilities. Maybe not always nitrogen, because sometimes difficult to implement in smalls, but surrogates, which have been under validation to give the same way of some good preservation of tissue for further techniques. So that's part of it. And we try our best to get all the techniques work on paraffin, because actually we do need to do paraffin still embedding to make a diagnosis. But all genome sequencing, which is a huge, huge task, Genomic England and NHS England have done their best to try to get it to work on paraffin, but it doesn't give nice results. So we'd like to perform all genome sequencing on frozen tissue only, so we can find ways of freezing also biopsies in parallel to paraffin. But if we don't have frozen tissue, we'll be able to do wide sequencing still. Not all genome sequencing, but quite a wide for being able to answer all the questions.